Hi everyone, in this video we are going to talk about how we can solve questions involving the Born-Haber cycle. In particular, we are going to look at how we can draw energy level diagrams to answer such a question. Alright, so the thing that we are looking at today is Al2O3 solid. Alright, if you are able to do this on your own, it will be very good. Alright, so let's start with our task. So we'll start by drawing down our axis, okay, with energy, and we are going to start with this ground state arbitrary value of 0. Okay, and this is where we'll get everything at ground state. Aluminum exists as solid as standard conditions. Oxygen occurs as O2 gaseous. Alright, and we need 3 of them, so the coefficient is 3/2. This is going to give us our Al2O3 solid. Okay, so one thing for you to note, please connect the arrows and the lines to the horizontal lines itself. And of course, it is important for us to use a ruler. Do not follow my example over here. Okay, and so in order for you to tackle Born-Haber cycle questions, you need to remember a series of steps. So it is just algorithms, but there are tiny little details that you need to take note of. So the first thing that I'm going to do is I'm going to target parts of this different parts of this structure. Alright, I'm going to look at Al first, then I'm going to deal with oxygen. So what I want to do is to turn both of them into the gaseous state first. So the first thing I'm going to do, stage 1, is to convert my Al to Al gaseous. Sorry, there should be a 2 here and a 2 here. Alright, so I'm going to convert it to this form, and I'm going to copy my 3/2 O2 gaseous. Then in the second step, I'm going to work on my 3/2 O2, and I'm going to get 3 oxygen gaseous. Okay, whereas I copy up my Al gaseous over here. And so it is important for us to take note that these are some of the equations that we have already known. So the first one is actually delta H, atomization of Al. Right, and because there are 2 Als here, I need to multiply this coefficient by 2. Then in the next step, okay, I need to convert my 3/2 O2 to this. So this is the delta H atomization of oxygen. Okay, so because I need 3 oxygen, this will be 3 over here. But of course, to get this delta H atomization, you can also use 3/2 of the bond energy of O11O, which you can find in your data booklet. Okay, so this is what we have so far. So stage 1 is complete. Let's look at stage 2, where we want to create our gaseous ions. So we know that Al needs to become Al3+. So what we are going to do is we are going to combine the first IE, right, the first IE to form Al plus the second IE, right, to form Al2 plus the third IE of Al to form Al3 plus. But because there are 2 over here, I need to take 2 times this value, and what I'm going to get at the end of the day is 2 Al3 plus gaseous, okay, plus 3 oxygen gaseous. So this is what we currently have. And the next thing that we need to do is to ensure, right, sorry, there should be 6 electrons here, right, and the next thing that we need to ensure is that all the oxygen becomes O2 minus. So what is important is that we need to give our oxygen 2 different electrons, but each oxygen getting 2 electrons with 3 different oxygen atoms, there should be a total of 6 electrons. So there shouldn't be any electrons left dangling around. All 6 of these must be consumed. So we can present our answer this way, where we copy down our 2 Al3 plus gaseous, but for our oxygen we can add 3 O minus gaseous plus 3 electrons. So we have already taken in 3 electrons in this case. So this is the first Ea, alright, but this is 3 times of the first Ea. And we all know that the second Ea is endothermic, so it is once again 3 times second Ea Okay, and I have my 2Al3 plus, right? Notice all the black color wordings is when I just simply copy the values up, then 3O2 minus gaseous. So all the electrons have been consumed. This is what I have, and well, this is a bit of a stretch, but if you draw all the way down, this is our lattice energy. So all we need to do at the end of the day, usually we are asked to calculate the delta H formation. We just have to start from here, which is this is the starting point here, this is the end, and we have to go through the whole process of applying the Hess law. So we start from this point, so we take this plus this plus this plus this plus this plus this arrow, so that we can get the value of delta H formation. So if I were to write everything down, right, delta H formation will be equals to 2 times delta H atomization plus 3 of Al plus 3 times delta H atomization of oxygen plus 2 times first plus second plus third IE of Al, okay, plus 3 times first plus second EA of O2 plus lattice energy. And so using this stepwise process, we will be able to get to our answer. So let's review this process again. Right, the first thing that we need to do is to form the gaseous atoms. Right, so we need to use delta H atomization or bond energy in certain cases when we are not given the atomization values. Then the second step is for us to create the gaseous ions, right, over here by using our IE and our EA. Right, so the common practice is that we can group things together. So instead of presenting this in the our EA in this manner, we can just group all our EA values together. Okay, as long as they are the same kind of reaction. So we can group our EAs together, IEs together, things like that. Okay, and the final step is we want to make the solid by using lattice energy. Okay, so this is our last step. So altogether there are 3 steps, but many tiny details, which means there are many areas where you can make potential mistakes. So please look out for them and be very careful. So to wrap this up, let's check our answers. Okay, I want to make 2 aluminum atoms, so 2 is correct. I want to make 3 oxygen atoms, this is correct. Each of this aluminum, okay, needs to take 3 give out 3 electrons. So first, second, third, there are 2 aluminum atoms. Right, first and second EA for my oxygen, 3 of them, lattice energy. Alright, and it points downwards from the gaseous to the solid form. My equations balance, there is 2 here, 3 over 2 here. Okay, so 2Al, 3 oxygen, this is correct. 6 electrons, this is correct. 3 electrons used, so this is correct. No more electrons at the end, so this is very good. Okay, there is 0. Alright, to mark the ground state of all your elements at its standard condition. We have the right axis, which is energy, so this answer will be correct. So what I want you to take note is all these tiny little details that might cause you marks, so be careful when you're tackling such questions, and remember to check through like how I just checked through.